Hello everybody. In this video we will learn about section 2.8, that is we will learn about one-to-one functions. One-to-one functions. So these are special kinds of functions. To define one-to-one functions, it is a function with domain A is called a one-to-one function if no two elements of A have the same image. That is, f of x1 is not equal to, if f of x1 is not equal to f of x2, then whenever x1 is not equal to x2. So an equivalent way of writing this condition is f of x1 is equal to f of x2 whenever x1 is equal to x2. So this is equivalent to the above condition. So why are these one-to-one functions important? So not all functions will have an inverse function. That is, if f goes from A to A, will we have a function f inverse which goes from B to A? So is it possible? It is not possible always. It is possible only if f is one-to-one. So we write it like this also. So f is one-to-one, only then only one-to-one functions will have inverse functions. So if you have to draw an arrow diagram, I will draw an arrow diagram for a function which is not one-to-one first, so that you will understand better. So suppose if this is A and this is B, and A is the domain and B is the codomain, and if you have elements x, y, z and P, and if you have 1, 5, 6 and 8 in B, so if f takes the values x to 1, y to 5 and y to 8 and z to 6 and P to 8 as well. So here you can see that this is definitely a function. Why? Because every element has a unique image. It's true. When it will not be, I'm sorry, yeah, I should not have included this line, yeah, and this line too. Okay, I will mark z to 5. Okay, so this is definitely a function. Why? Because you have every element has a unique image, but two elements have the same image. So this is a function, but this is not 1-1. So hope you understood what is the difference between not being a function and not being a 1-1 function. So now we will make this 1-1, make f 1-1. So to do that, this is A and this is B, x, y, z and P, 1, 5, 6 and 8. So we have, if we mark, every element has a one and only one image. No two elements will have the same image. So this is definitely a function. The function as well as a 1-1 function. If I mark this function as G, so this is 1-1 function, one-to-one function. So now you understood what are one-to-one functions. We will now establish a graphical test to find out whether a function is one-to-one or not. So suppose you are given a function, or a graph of a function looks like this. So let it look like this. If this is x and this is y, this would be f of x. The function looks like this. So now if I draw a horizontal line Okay, I will draw a horizontal line across the graph, so that now this horizontal line touches at two particular functional values, if you can see that. So if this is x1 and this point is x2, so this would be f of x1 and f of x2. What does a horizontal line mean? That the y values for this line, that is the red line, is the same for all the points that lie on the line, correct? For all the input points, the functional values of this straight horizontal line is same. Therefore, f of x1 and f of x2 are equal, but x1 and x2 are not equal. So this tells us the given function f of x is not 1, 1. So this is a horizontal test, horizontal line test. We did vertical line test before. Now it is horizontal. Vertical line test was to identify whether a given graph is a function or not. So horizontal line test is to find out whether a given graph of a function is a 1, 1 function or not. That is 1 to 1 function or not. So we will do some exercises based on this, and we also can apply the definition to find out whether a given function is 1 to 1 or not. So we will do some exercise problems. First I will do problem number 8, which says that a graph of a function f is given. Determine whether f is 1, 1 or not. Okay, so the graph looks like this. I will need okay, so the graph is somewhat like this. Okay, so this is x axis and this is y axis and this is the origin. So now if I draw a horizontal line anywhere, okay, if I draw it here or here, so anywhere, whenever I draw, the green lines are horizontal lines. So whenever I draw the horizontal lines, it is touching the functional, the graph of the function, or touching the curve only at one point. Therefore, it is a 1 to 1 function. Okay, so the you need not check whether it is a function or not, because the statement itself says the graph of a function. So these are already functions. You just have to check whether they are 1 to 1 functions or not. So now while applying, this was number 8 in your book. Okay, so now while applying the definition, if you have to apply the definition, so this is number 16. The question doesn't say like you have to apply definition or the graph. You can do it both ways if the question doesn't specify whether you use a graph or whether you use values. So but a graph, plotting a graph is little difficult to identify it as a function. Using definition is always easy. Okay, let's do that. Given is g of x is equal to absolute value of x. So what does the definition says? I will use the equivalent part, that is the equals part for it. If x1 is not equal to, sorry, if x1 is equal to x2, or sorry, you have to establish that if two functional values, that is g of x1 is equal to g of x2, then you have to prove that x1 is equal to x2. So this is how you use the definition. So let us do that. We assume g of x1 is equal to x2. So what is g of x1? It is absolute value of x1. And what is g of x2? It is absolute value of x2. Correct? So when absolute value of x1 and x2 are equal, it is can there be a possibility of x1 not being equal to x2? Yes, because absolute value of x1 when x1 is negative will give back x1 itself. When x2 is if when x1 is less than 0, you will get minus x1 as a value, right? So this can be negative x1 also, correct? So that, but if x2 is positive, so you can have this scenario also, like negative x1 is equal to x2. So this doesn't imply that the given function is 1 1. So you can check that using graph also, plotting the graph. So y is equal to absolute value of x. Okay, so you can see how the graph looks like. And if I draw a horizontal line, okay, so if this line, it is touching the graph at 2 points, this point and this point. Therefore this definitely is not a one-to-one function. Okay, so let us do another one where it is a one-to-one function, that is number 24. I have solved it so I can find out whether it is a one-to-one function or not. So which states that f of x is equal to 1 over x. So now again, using the definition, f of x1 is equal to f of x2. Consider this first. So prove that, using steps, prove that x1 is equal to x2. Okay, so how do we do that? F of x1 is nothing but 1 over x1 and f of x2 is 1 over x2. If you undergo a cross multiplication process, so you will get x2 is equal to x1, which is same as x1 is equal to x2. So this is satisfying the definition of one-to-one function. Therefore f is a one-to-one function. So let us verify this using the graph as well. I'll clear the old graph. So y is equal to what was the thing? Okay, 1 divided by x. Okay, so this was the graph, correct? So if I choose a pen and draw horizontal lines, okay, like this. So you can see everywhere, if I keep drawing horizontal lines, it is touching the function only at one particular point, here, here and here. Therefore this is definitely a one-to-one function. So what we did using the definition is correct. So now you understood what is a one-to-one function. In the next video we will learn about inverse functions and how to find the values of inverse functions. I will give all the quiz questions in the third part of the video, collectively, like the one that is stated in the PDF file, that is 2.8.1, 2.8.2 and 2.8.3 in one video. So I am solving certain questions that are in the exercises itself. So if they are in the homeworks, so you can go through the video for better understanding. And if you still have some problem with your homeworks or quiz questions, please come to my office hours. It would be better if you email me beforehand so that I will be prepared for that questions. But it doesn't matter, like if I have covered the videos, and I would definitely have studied it, and I would have solved some problems based on that, and I am in a better position to answer all your questions. So this completes the part 1 of section 2.8. See you soon with part 2. Thank you for listening.